Yeah, so first a disclaimer is that I called this AI, How AI is Right Explained Like You're 5, explaining technical things. I wanted to make sure nobody was scared off. I am going to explain it like you're 5. That is an online thing. I don't know if you're Reddit users, but ELI5 is a thing. Somebody will say, I need to know about neural nets ELI5, and that means explain like I'm 5. So I'm piggybacking off of that, and yet when I have a theme, I run with it. And so that's why name tags are a little silly, and I might take mine off simply because my hair keeps getting caught in it. There are glow sticks and lollipops and pens and goodies on our tables. And so do not get offended if I treat you like you're 5. It is the theme of the day and not a commentary on any one faculty, okay? I'm just trying to have fun. And I'm also just trying to loosen us up and get us to talk about some things that maybe aren't comfortable in our comfort zone for everybody. And I want you to know that that's fine, okay? It's okay. You can ask any questions that you need to ask. So while folks are still coming in and eating, Paula says that we should talk to ChatGPT just in case. There's someone here who has not played with it before. So what would you like to ask ChatGPT?
Why the word engineering is in prompt engineering.
Okay. Engineering in prompt engineering. The word engineering in prompt engineering likely refers to the process of crafting or designing prompts for a natural language processing model like GPT 3.5, which is what I'm using right now. In this context, prompt engineering involves carefully constructing input queries or statements to the model to elicit specific and desired responses. It is a crucial step in utilizing NLP models effectively to get the desired output or information. And now I'm going to write, I'm only 5. I don't understand. I don't know about you, but that's a lot of buzzwords. Please explain again. Of course, I'll explain it in a simpler way. Prompt engineering means choosing the right words and questions to ask a computer program like me so that it gives the answers you want. It's like asking a question in a way that helps you get the best answer. Just like how you ask questions to get information from grown-ups. People do something similar with computers like me to get the information they need. Okay. So you can see that we can chat. I'm not going to belabor the point because I know everything that is about ChatGPT starts with, and this was written by ChatGPT, right? And I'm not going to do that to us. So I really want to spend our time, but are we good? You've seen it. You understand that it's very remarkable, isn't it? Remarkable, an amazing feat. I start before you turn 5. With just a tiny bit of vocabulary. I have my PhD in artificial intelligence, specifically in the area of natural language processing. I've been doing this since I was an undergraduate, so more than half of my life, because I had a wonderful undergraduate research mentor who worked in that field, and he got me interested in it, and I went on to get my PhD in it as well. So just so you know, I've been doing this longer than I have not been doing it, okay? And I'm going to tell you that right now in the media, when people say AI, they generally are talking about generative neural networks, this ChatGPT type stuff. That's what they generally mean. However, that is not what the term artificial intelligence means. That's what the term means right this minute, okay? Artificial intelligence is a much, much larger, broader field that includes all kinds of different ways to solve all kinds of different problems. As a subfield inside of artificial intelligence is a field called machine learning. Machine learning is looking at only those types of problems for which we cannot directly describe what we want the computer to do. I don't know about you, but if you try to explain somebody, how do you choose your words? That's a really tough, it's so innate. we don't really know how we do it. How do I look at a face and know that that is my friend Stephen? I honestly don't know how I do that. I just do it, okay? If I tried to describe it and started talking about 2 eyes and a nose and a mouth, y'all would be like, yeah, all of us, right? It's hard. We can't describe it. So machine learning is good for those kind of problems. So problems where we don't know the patterns, we want the machine to find the patterns for us because we don't actually know how we do what we do. Within that, there are many, many types of machine learning. Within that are neural networks, which is an algorithm, that's, boys and girls, just a way to solve a problem. That's all I mean. And y'all call me out if I use a word, okay? You tell me. But that's just a way to solve a problem that is inspired, it uses a math model that is inspired by how our brain works. That's all. It's a type of mathematical way of expressing and solving a problem. When I was in grad school, none of my AI friends were in neural networks, and that is because they didn't work very well. The technology's been around for a long time, but they weren't working really well. So one of the things you're going to learn today is why all of a sudden they started working. And so we'll talk about that. Within neural networks, you can use neural networks to learn lots and lots and lots of things. Within it is the idea of learning about how to use language and how to generate language as a human does. And that is the ChatGPT that you just saw. Okay? So I want you to understand that we say AI, or the commercial with Usher says AI, right? And what they really mean is this kind of right now thing. And so what we mean when we say AI in 10 years, that people might not be talking about this anymore. It'll be whatever the next thing is, okay? So this is a term that the media will change as needed, okay? So we're going to start now, and we're going to start by learning how neural networks learn. I'm going to tell you a story, and then we're going to play a little game. It's going to teach you how neural networks learn. The story is this. We all went to the arcade last night, didn't we? You remember? Yeah, okay. And you know how you do it at arcade? You play games, and every time you play a game, you get little tickets, yes? And at the end of playing, what do you do with your tickets? You go turn them in for prizes. That's right, for fabulous, wonderful trash, right? Yes, and that's what we do. Well, last night at the arcade, there were 3 bags left on the counter. And these bags have some little prizes in them, and a receipt saying how many tickets were spent. What we don't know, and by the way, in the bags are lollipops and pens. And if you don't get a bag, don't get upset. There's lollipops and pens on your table. You can have some, okay? But there are lollipops and pens in here, and we don't know, nobody knows, nobody in the room knows how many tickets it takes to buy a lollipop and how many tickets it takes to buy a pen. Are you with me?
Yep.
Good. So we're going to learn it. We're going to learn it all together. Who would like a bag? Since I picked on you, you get first. Okay. So if you'll open your bag and tell us what you find. Okay. Okay. And a glow stick. And do you have a receipt in there?
I do.
Okay, what does it say?
It says 2 lollipops, 1 glow stick, 8 tickets.
8 tickets. Okay. Can someone take a guess? It can be completely random. It doesn't have to be necessarily based on what Stephen told us. Somebody take a guess at how many tickets a glow stick might be.
4.
2. And how many a lollipop might be? I heard 4, so can we... 4? Let's use 1. Let's use 1. Okay? All right, so we're going to take a guess. All right? Just take a guess. Now, if we use our guess and we unlock some more data, maybe our guess can get better. Okay? All right? I want you... Did anybody do any math? I hope not. Don't do any math. You're thinking too hard. You're thinking too hard.
Only 5.
Yes,
Only
don't.
5, I can't do
Oh, that does remind me. Yes, that does remind me. Since we are only 5 if we need math, I'm going to entrust Antoinette with our very large calculator, okay? Would you like a bag? Can you tell us what's in your bag?
One glow stick,
Okay.
2 glow sticks, lollipop.
All right.
Survey says
So it sounded like
7.
2 and 1 and 7. Okay? Now, if glow sticks were 2, for real, and lollipops were 1, how many would 2 glow sticks and a lollipop cost us?
We're not doing math today.
That's right. We can do it on the calculator if you want. Okay, how much would it cost us? Do you know?
Say again, 2 glow sticks.
2 glow sticks and 1 lollipop. It would have cost 5. Okay? Our guess comes out 5. However, Deb said the answer is 7, which means what should happen to our guesses? Something has to go up a little, doesn't it? Okay? So I can go up a little on something. Are you getting the idea here? Okay. On one last bag. Somebody on this side of the room wants a bag. Thank you. Open and tell us what you find.
How did you do on the first one?
2 glow sticks. 2 lollipops.
2 lollipops. How many tickets do we have?
If it says 6, I'm going to be upset.
If it says 6, something's
Glow
wrong.
sticks, 10 tickets.
10 tickets. Okay. If we had it right, 2 for pens and 2 for lollipops, how much would 2 of each cost? Would have cost 8. You with me? 2 lollipops would have cost 4. 2 glow sticks would have cost 4, and together it would have been 8. Okay? But it was not 8. It was 10, which means our numbers need to go up. Okay? And so if we, see why I didn't want to do it the first time? I was afraid. Okay? I was afraid. I didn't want to, okay. So if we guess and check and tweak, and guess and check and tweak, and guess and check and tweak, and tweak. Okay? That's all we're doing. Are you with me? Okay? Now, at this point, if I were to go back and look at 1, 2, 8, do you think what do I need to do? Do I need to raise or lower our numbers? That one worked out, didn't it?
Yep.
And 2, 1, 7, do I need to raise or lower our numbers? Or does it work out? That one works out. And 2, if you don't know, just somebody's saying so, just go with them, okay? 2, 2, 10, would that work out? It works out. At some point we stop tweaking the numbers, okay? At some point we stop tweaking the numbers. You now know how a neural net learns. And you say, but Shannon, I didn't do any fancy math. Correct. Absolutely correct, okay? Now, nobody knew when we started how much a pen costs. And our bags didn't directly tell us. Otherwise, we'd have just written it down and been done, right? And yet we have some information, some evidence that is based off of how things are working. And basically what this math model allows you to do is reverse engineer from a result how to get the result. So we have the result, which in our case is humans using language, but we don't really know how we do it. And what neural nets allow us to do is to pull apart the result into component pieces so that it starts to learn how it works. How confident do you feel that we have the right answer here? I'm going to read you another receipt. 3 lollipops and 2 glow sticks is 13. Feeling good? Yeah. Okay. So you would bet on it at this point probably, right? Bet on it? Oh, until I...
We
money.
I won't take your lollipop. Just, okay, it's all right. You can have your lollipops. All right. Okay, did we prove it? Have we proven this mathematically? Absolutely not. No. I'm sorry, but no. I have a mathematician in the room. I have to make sure I said, no, we did not prove it. We didn't prove it. We don't really know it. The evidence suggests that it's correct. Now you can say, well, Shannon, this is a linear combination, and so there's only so many possibilities, and so yes, we can prove it. No, you're only 5. We don't know. We haven't proven it. We have not proven it, okay? We have not proven it. We have evidence that shows it, okay? Now, what the very smart mathematicians can tell us is that for many, many, many types of problems, we will eventually stop tweaking the numbers, okay? And when we stop tweaking the numbers, then we call that convergence. The model has converged on what we believe to be as good as we can get, okay? And truthfully, in convergence, you still might tweak just a tiny little bit, but it's so small enough that you feel like you don't care anymore. Did I lose anybody?
I believe they call that a probable outcome.
Yes, exactly. Yes. Okay, so we know within a certain percentage that we feel like we have it right. But I do want you to understand we didn't prove anything, and we didn't derive a formula for this. We did not. We are guessing. Okay, guessing. Now, one of the bags was red, and the other 2 were brown. Okay, what would have happened if having a red bag secretly cost you a ticket or 2, and we didn't know? Would our model have ever stopped? Would we have stopped tweaking our model? Would our model work? The previous one? No. We would always be attributing the things to those 2 things, and we would always be tweaking to try to make up for it. Agreed? Okay. If I put a circle here for having a red bag, so now I'm going to have the number of glow sticks, the number of lollipops, and the number of red bags. Okay, and I'm going to learn that, and I have my tickets. Do you think this would work? Would I learn that the bag costs 0?
Maybe, maybe not.
Maybe, maybe not. Anybody feel strongly one way or another? We would. We would eventually learn, probably because think about it like this. What if you open 1 glow stick, 1 lollipop, and a brown bag, 1 glow stick, 1 lollipop, and a red bag, and they're the same price? Would you learn that it didn't matter? Of course you would. So having an extra circle that doesn't matter, the model can handle that. This edge that we are learning, the number that goes on that edge, it would just be 0, and we'd learn that. We would learn that, okay? So there are some things that having it part of your model or not having it as part of your model can make or break this thing. And that is why 20 years ago, a little more than that, sorry. And I was in grad school, we weren't working on neural networks. And that is because back then what we would do is we would study a problem, we would define all the things that we felt were important to solving the problem. Okay? And that's called feature engineering, okay? Features. And then we would try to learn. And inevitably, it would just not stop tweaking. But now we have computers that are fast enough. We have so much internet data that we have tons and tons of data, and we can build networks that are huge enough that we don't have to any longer decide what's important on behalf of the computer. We give it everything now. Do you understand? So that is one of the big reasons why all of a sudden it worked, okay? That you live in a time where that much memory and that much processing power is available, okay? So this is largely why it wouldn't have worked before. Now, let's say that the arcade is having a buy one, get one half price sale on lollipops, okay? How would our model do with that, do you think?
Iterations do we have?
Right, so we start to ask, like, are we going to need more data, right? It's a more complex problem. Something's going on underneath. You wouldn't know that starting. You would just have tickets, right? Okay? And it turns out that this kind of model would really struggle to learn that because there isn't a single price for, what did I say, lollipops? For lollipops. However, if you string these together, we can learn much more complex mathematical things. Okay? Now, what does that mean to string them together? The inputs are, I have this many of this, and this many of this, and this many of this. The eventual output is whatever I hope I can predict what's on the ticket, yes? And the numbers in between tell us how much to weigh each of the inputs in order to get an output. It tells me what do I do with that, okay? Imagine putting the output of this as the input to another set of circles. And in particular, imagine having more than one line going out from lollipops, where I can send half the lollipops that way and half the lollipops that way. I can get my buy one, get one going now. Do you understand what I'm getting at? So by adding more circles and more lines, we can get much, much, much more complex mathematical behavior out of these networks. If you pick any circle that is not the leftmost circle, do you know what math that circle's doing? In ChatGPT, in something real, not for 5-year-olds, it is adding up, multiplying the numbers that come in and adding. It is doing exactly the math you all were doing without even needing the calculator. That's the math it does. I'm not dumbing it down for you. That's all it does. But just like cells don't seem to do much in isolation, when you put them all together and they actually are working together, you get this emergent behavior, which is hard to even, it's so complex, hard to even wrap your mind around. That is exactly what's happening mathematically, okay? All right, so that's a neural network. Questions? Are you having fun?
Yeah.
Okay. All right. Couple things I want to say is that that this is not a brain, okay? This is a mathematical model. It has no biology in it. There's no biological matter in it. It's made out of circuits with electricity, which is not what is inside of your brain, okay? So it is not a brain. I'm not building a brain. I'm not even trying to build a brain. If I were trying to build a brain, I'm not going about it really well because I don't even have the first block. We use, in computer science all the time, we are inspired by things we see in nature, by the way that we see math patterns running, and we try to adapt them to solve problems. That's all this is, okay? So please understand that. It's not a brain. It's not even how your brain works. We don't really know all of how our brain works, okay? It's just inspired by the fact that we have neurons that send signals to one another, that are connected to one another, okay? It's inspired by that. Second thing is, I want you to understand that if we have this model, and we feel very confident about our model, right? We feel that we can accurately predict how many tickets something will cost, and we feel that way. If the arcade changes its ticket structure, okay, our model will start to not work. And what will we need to do? We will need to go back to the tweaking part, okay? We will notice, oh, our model is off now. It's not working. Something must have happened. Something must have changed. We don't have to necessarily change the structure with the circles and the arrows, but we have to go back and enter the learning phase again. Please understand that when we used ChatGPT at the beginning of the lesson, it is not learning. It had already learned, okay? It would take a very long time for it to get back to me if it was actually learning as we went. That is a massive thing. It is more complex. What all it's doing is taking a model it already learned and using it. Just like if I said, how much is a lollipop and a glow stick, you could use this information and tell me fast. Agreed? Okay, so I need you to understand there's a learning process. You were not part of that, except for anything you post on the internet was, but all right? Okay, and
Thank our parents.
yes, and then there is a using time, okay? All right, that's important. All right. All right, so now we know how neural networks learn. I promise you it is predict, tweak, predict, tweak, predict, tweak. Okay? But we have a couple problems for our understanding of ChatGPT. The first of which is we have used solely numbers up to now, and math and numbers tend to work well together, and math and words, how are we going to do that? Okay? Now the next is a game I played with my undergraduates, but for time's sake, I'm not actively going to do it here. I'm just going to show you what they did. But what I did was on the a document camera in my classroom, I put a bunch of magnetic poetry words and put a sheet of graph paper underneath that. And then I picked on somebody to come to the document camera. And the student's job was to rearrange the magnets such that there was some order to the words. They weren't random anymore. I didn't say what that order needed to be or anything, really. I just said, push them around until you feel like you've ordered them somehow, okay? And they came up with this, okay? They came up with this. So let's examine some of this. And by the way, I kept adding more words as they went. So it was a lot of fun. If you do this in class, I take my advice. Keep adding words, it's fun. Okay, so let's look at some of what's going on here. They put the foods together. They put the animals together, but they had one that belonged to both. So they kind of made an overlap in their minds where it could be pretty close to the food and pretty close to the animals. You get what I'm saying? Okay. They did the same with things that have wings. And so they have the animals, and they don't want to put an airplane in the animal section. So they kind of push the airplane over but put wings in between as a connector, isn't it? It's a connector kind of. And then they did this. Woman and man are up there next to each other. King and queen mirror the relationship that woman and man have, don't they? Such that you could even imagine doing a woman is to man as queen is to blank and being able to use this picture to come up with the answer, couldn't you? In a sense. Okay? Yes? Now, I didn't tell them what to do. I didn't say put all the pronouns together. I didn't say put all the nouns together. They might have come up with a very different thing because some of these, are different, right, for that.
So does it look the same every time you do the exercise with the students?
Oh, I only did it once, so I don't know.
Okay.
I did it once, took pictures. It is a very good question. It is a very good question. I'm sure not. And as I added words that they realized now, oh man, I should have put that word near that word, and it got very complex. They started wanting to hover the words on top of the document cam, which is a really good intuition, actually, okay? Because it turns out putting them all flat might not be complex enough to, oh look, I saw light bulbs all over the room. It's wonderful as a teacher to see that, right? And and so you might want to be able to represent more complex relationships than I can do if I have to lay them flat, okay? But I did not tell them how or what criteria to use. They just did it, okay? Now, how could I turn each word into a number? Well, there's a hint in the background. What do you see in the background? Grid. How could I turn each word into a unique pair of numbers? I could do columns and rows. And since you're 5, you don't know about X and Y, but you know about columns and rows. You can count how many blocks over, how many blocks up that word appears. Agreed? Mm-hmm. And those numbers would tell you which word I was talking about. Moreover, those numbers have some meaning in them because the distance between woman and queen and the distance between man and king and the distance between wing and butterfly and wing and airplane are trying to be the same. So the things that are used in a similar way end up being together, but I don't have a definition for similar way. It could be that it's used in a similar way because they have wings. That's the structure of the thing it's referring to. It could be used in a similar way because they're both nouns. It could be used in a similar way because when I read so-and-so's Twitter feed, they always use this word. You see what I'm getting at? I don't know what the similar way is, just a similar way, okay? And this is how neural networks learn with numbers. We simply map each word to a set of numbers that it makes it unique, so we know which word goes with which number, okay? And then we use a neural network to learn which numbers give us the best relationship information, okay? This is something that has been done decades before now. This is kind of a known thing we've been doing, because what we want to do, before we were able to generate language, which is really hard, we were able to start to understand it or categorize it, right? That kind of thing. And so we have been able to do this in the past. This is called word embeddings. And it means that we have numbers that represent words, and those numbers are actually kind of meaningful in terms of how the words are used and how they relate to the other words, okay? I will tell you that if you use ChatGPT or read about it, you will read about tokens instead of words. Tokens are used instead of the word because there are more words in the English language than they can use right now. Again, I remember size is an issue here, right? And we want to give it everything, but I don't want all the possible words, because it wouldn't just be all the possible words in the language, it would all be all the possible ways we all misspell those words, right? And it would be words that we'd never even heard of before, like ChatGPT, not a word till now. Do you get what I'm saying? And so some things are pieces of words, like maybe ment as a suffix, which has its own meaning and way of use, even though it's part of a word. And maybe even a phrase like ChatGPT, which is a one thing, even though if it has two, or ice cream. You see, I put ice cream as one magnet, even though it's two words. It doesn't quite mean the same as cream and ice together. So that's why we use the word token. Do you understand? It mostly means words, but not exactly, okay? All right, so back to AI, how AI is right. But before I do that, questions so far? You with me? Yes. Yes, of course.
So that initial learning that took place where the words became numbers on
Yes.
a grid, did that create the structure? Like the computer didn't know going in what the structure would be, just like your students didn't know? So
It depends on what.
Frequency, or like how did the computer decide where to put words close together?
Yes. Okay. So this is a learning thing where what we asked is that when words are used similarly, we want the distance between them to be small.
Okay. So it's just how we use it.
Yes.
That's how we get it.
Okay. So we now know how neural networks learn, yes? And we know how we can use words as if they're numbers and do math. Y'all with me? Okay. But what is it that we are learning exactly? Okay, that's the next question. And the answer, again, is a language model. The answer, again, is a game that I play with my students, but I will not make you do, because I did in the last workshop, and they were not very happy with me. So I will not make you do it. But the idea is, what I did with my students is I have had 11 students, and they wore a little sign that had one word on it. And then we took yarn, and we made sentences with our 11 words, and we strung yarn to show the direction of the sentence. They loved this. And so if you are teaching this, as I absolutely recommend, if you're teaching this, use this. You can use my slides, you can use everything, you can use the games, okay? They loved it. They had a great time. But what we're going to do is just pretend, okay? So the first thing, so here are our 11 words. I am, have, saw, a vision, cat, many, runs, that has isn't supposed to have a thing there, but we're going to ignore it, okay? And And I want you to start with the word I. Want you to start with the word I. And someone make me a sentence.
Saw
I saw
cats that runs.
I saw
Many
many
cats. Can I say
Cat.
cats?
go for it.
Runs.
That runs. Okay? Somebody else make me a sentence. This only works if I get more than one sentence, y'all.
I have a vision that has a cat.
I have a vision that has a cat. Another? Mm-hmm.
I am a cat that has many visions.
Nice.
Or that has, I can't, I have to have a vision.
Cat
I can't make a new word, right?
that
No, you can.
has.
Or many.
It's okay.
Can I make a new one?
Visions.
In kindergarten, there are no rules. So, welcome. Okay? All right. If we do this for enough sentences, all right, this becomes a language model. You can imagine how fun this was with yarn, yes? The person making sentences ended up in the middle, all strung together, and it was a lot of fun. So it is good. What this is a language model. I can use this language model to generate more sentences, okay? I'm going to do that by following the arrows in any way I want. I have a cat that runs. I don't believe that was one of the original sentences. But do you see it in here?
Yeah.
And is it grammatical and does it make sense?
Yes.
Nice. You get the idea? Okay. I have a vision that has a cat, that has a cat, that has a cat, that has a cat. Do you get what I'm saying? All right. Have you played with autocomplete on your phone? Okay. So if you get out your phone and you act like you're going to send me a text, you're not really going to send one. Okay? And you write, the best thing about this workshop is. If you were to write that, the best thing, the students love doing this too, by the way. They actually want to send it to you. The best thing about this workshop is, somebody read me, and then what you're going to do is you're going to do whatever autocomplete says, the middle button, just keep hitting the middle button. Okay? The best thing about this workshop is, somebody read to me.
The way it will look for you.
The way it'll look for you. Mm-hmm. The
Other people.
in the
Yeah.
the best is that really
Yeah.
the same thing?
Same thing. And the other people.
That is so unusual. Very unusual.
To your place to do your project.
That's
If you
weird.
delete them,
Yeah,
it
it's-
changes the middle word.
Oh yeah,
If you
for
backspace,
sure.
It changes the middle
Because
word.
you didn't like
The
that
best
one.
thing
so.
about this workshop is that I have to do the same thing to you.
I think we have a winner. That's got to be the best answer to this question.
I'm gonna send this to somebody.
Yes, you should. A random person. This is what my child does, by the way, when she picks up my
And a
phone.
good night.
So, yes. All right. So what's going on is a very simple language model just like this. It either takes a language model that was given to it, which I suspect is why things come out the same, or it learns it based on your own text, which is probably a setting thing. And it will take the arrow that has the most outgoing ones. So it's going to take at each step the most probable next thing. Okay, so if I have 4 arrows going to the same thing and 1 arrow that goes over there, then 4 out of 5 times it's going to pick that one, and 1 out of 5 times it'll pick the other one. Do you understand? Okay? This is why autocorrect, this is how it works. This is how our autocomplete works, but also why you get very strange sentences that can sometimes go in a circle, just like I did. Do you get the idea here? So this is what you are learning. What the neural net is learning is, given a few words, what's the most probable next word? That's what it wants to know. So the input numbers are the words we have said so far. The output number is what it thinks the next word most probably is. If you do that without very much knowledge, you get this model. If you do that with a much, much, much more complex model, you get ChatGPT. Do you understand?
Yep.
Okay? So we have how neural networks learn. They literally guess and tweak. How do we do this? How do we do math with words? We make some numbers and make a word assignment with each number, really. But over time, they actually have meaning there, and we find that meaning there. And then what is it we're learning? We are learning, given some starter text, what is the next most probable text, which is why ChatGPT makes you start, okay? Because it needs something to go on. Okay, are y'all with me?
Yep.
You now know more about how ChatGPT actually works than most all of the population. None of it is very difficult, but people don't really actually know how it works. But that's all there is to it. Not all there is to it. Okay? All right.
I had a question, and this is constantly improving because of the inputs?
This is constantly improving because of several things. One is that technology is constantly improving. In other words, I might have used a grid of 16 computers, and now I have access to 18, and so I'm going to try it again and try it bigger. And so bigger, okay, is part of what's going on right now. And so we're going to try it we're going to try throwing more circles up there, okay? And if you ask an AI person why that number, the answer in AI is just that's what works, okay? We don't, that's the field, that's my field. So if it were the kind of thing that we could derive or we could know mathematically, optimally, it would never be an artificial intelligence problem to start with. Artificial intelligence, we don't know, okay? And so that's what works. And so by trying different things, you happen on things that work. The other thing, and we'll talk about this at the end, but some of the things that we are able to do things smarter, as in the math that the neural net does do, takes some time, and we can figure out how to make that same math faster, then that opened a floodgate. But the math is not any different. No matter what neural net and how complex it is, that's the math. Okay? Yes?
So would you have to create an entirely new system for every language, or do you attach this to like a translation?
So right now, state of the art right now, is you learn one language model for one language. We've just now been able to do it.
Right.
Couldn't do it. If I tried to make one model that could handle all the languages, how big would that thing need to be? Do you get what I'm saying?
Yeah.
The important part is when you think, oh, this isn't fair because it's in English, you're not wrong, right? That's not fair. It's in English. I don't have this tool for other language other than English. Is that because AI people got together and went, we don't like those Spanish-speaking people? No, that is not why. The reason why is that is the only language that we have enough data to make the thing stop tweaking. You get what I'm saying? When you have a model as complex as it takes to get language right, you need tons of data to feed back and forth through the network to get all the links correct. Tons of data. We've just recently even had enough data in English, but we do not have enough data in any other language. So, is it an ethical issue? Yes, but don't vilify the technology because of it. The same technology could be used on, right? And if we had enough data and enough processing, and this would take a lot, maybe we could even have one model for everything. But we're not there yet.
So in countries or locations, governments where there are more restrictions on access, is that also going to limit the data that the computers can
Sure.
share?
Yeah, of course. Of course. If they want to be represented, then they need a way to get their data to OpenAI company or any company that's using this data. They need to make it available somehow. If that's not the internet because of access, then they have to find a way, right? That's exactly it, yes. Okay?
How did, just a question.
Yeah.
BARD, like that, and the CEO of Google said they had no idea how that happened.
Yes. Yeah.
It's like it went rogue and
No. It didn't go rogue. It did not go rogue. It did not go rogue. Remember that the network is so big and vast that we can't wrap our mind exactly around the emergent behavior that happens when we put tons and tons and tons of these little very simple things together. What happens in neural networks is that when you get, you have some behavior, let's say you're using 27,000 circles, and then you up it to 30,000 circles, and you give it the same data, that all of a sudden it learned that. Okay, why? Because you gave it enough circles that something that used to be generalized now is specific. It's just like the areas in your brain. You have an area for this and an area for that and an area for something else. Yes? I mean, come on, I don't know brain science, but there's lobes in it. Yeah, okay. Yes? Okay. So if I didn't have that area, then it would just generalize, do the best it can. Okay? But this is an issue. We'll get to there, but I want to show the whole model first.
I have no idea how this happened.
Yes. Yes, and yes. Yeah, we'll talk about it. I'll come back to it. Okay, I want you to understand that there are probabilities associated with these that have to do with how many times we said a certain thing, okay? So let's say that I showed you a model based on these words, and what was very, very probable is the sentence, I am a vision. That is very, very probable. Then who trained our model? Maybe it was Beyonce. Do you get what I'm saying? It wasn't Shannon, because I don't know I've ever said that, right? It's just not something I would say. That's fine. What if the models had a very, very likely to say, I have a vision? I have a vision. Maybe Connie Book trained it. She talks like that, yes? Do you get the idea? You get the idea? What if it said, I am vision? Well, Vision said that, okay? And if you have never watched a Marvel Avengers superhero, that might not sound grammatical at all to you. And yet, that was the very first sentence my husband saw in these circles. I am Vision, because he thinks MCU all the time, okay? So what I wanted to show you is this is data bias. This is what data bias is all about. If I get the sentences from someone who's never seen a Marvel superhero, that link will never exist. But if I get it from my husband, that link will be very probable, okay? And that is why we talk about data bias. Data is representative of the people who created it and therefore has the same bias as the people who created it, okay? So, who created the data, not the software, the data, okay? All right. So, what we have is a neural network. It does very simple math. Given the words in a sentence, it comes out with the most probable next word. This is called a base model. I put some things in the slides I don't need to go over because we talked about already, but just in case people are looking at these later, okay? So why did it happen? Now we've already talked about this as well. In 2017, Google published a paper called Attention is All You Need, which gave us some really fancy math, which allowed us to do some things on different computers at the same time. This is called parallel computing. When I can take a problem and break it up between two computers, I can get the solution twice as fast, but it's not always easy to know how to break up a single problem into pieces, and so they came up with that idea. So now, instead of feeding one word in at a time, which is what we've always done, now they feed in all the words at once with numbers on them. This is the first word, second word, third word, like that. They had other fancy math that let us break things into multiple processors. And then their big contribution was this thing called self-attention. Self-attention is a piece where we are going to learn, if we want to know what this word is, I would like to know which other words around me would be good to pay attention to, okay? So here's an example. I want to know what it refers to. If I want to know what it refers to and I want to do it correctly, I should hopefully pay more attention to the word Elon than the word Phoenix. Agreed? It is trying to act in place of Elon and not Phoenix. However, if the sentence were this, Now, I need to pay more attention to the word phoenix than the word Elon. Why? Because it and phoenix are used in the same way here. I would say that a phoenix represents hope. Do you see? Well, our math with words can tell us this, which things are used similarly, can't they? Ooh, right? And so, by using the math on the words, I can determine which words are better for you to pay attention if you're trying to understand this thing. Now, understanding the concept of a pronoun and resolving that pronoun is just one example, grammatical and easy to understand one. But after you've understood that we're talking about the phoenix, I now need to know about some of the rest of the words in the sentence. And so now maybe I'm interested in Elon. What is this Elon thing? Is this Elon Musk or what is that? Oh, I come up to, okay, university. Elon University is used with phoenix and all this a lot. Okay, good. And now the phoenix is representing this. Okay, interesting. I wonder what that phoenix actually is. Oh, it turns out it's a bird mascot, not just any phoenix, and probably not actually a real bird. Probably a big fuzzy one that you climb inside of, right? And it takes multiple steps. You can't do that all in one step. This is logic we're talking about. But you and I have common sense, most of us, okay? No, all of us in here, most of my students, okay? We all have common sense and our brain does it. And our brain does a lot of logic without us even knowing we're doing it. Okay, and so it's important that you use this attention mechanism is what they wanted to try to learn. What if, in discovering the answer to what this means, what if we kept feeding it the distance between all the other words around it? Okay, what if we kept doing that? And that just worked. And it got some behavior out of neural nets that we had never seen before. And this broke the dam. And that paper was called Attention is All You Need because of the self-attention mechanism. So here it is. This is my model of ChatGPT. Okay? You give it some words. Each word is an input into this neural network model. And out comes some more words. Okay? All right. Seriously. Let's zoom in. We're getting a little more detail than this. Okay? First of all, there are 2,048 input circles. Okay? When I give you specific numbers, I am talking specifically about GPT 3.5, otherwise known as ChatGPT for right now. Okay? Because I had to pick one. Like there's Bard, there's all these other models. I had to pick one to give you actual numbers. So I'm picking that one because that's probably the one most heard about, ChatGPT. 2,048 circles. They're not all full at the beginning unless you type a lot before you hit enter. Okay? So there's some empty ones. Everybody with me? Okay? What it learns is the next word. Then it decides mathematically, bing, bang, boom, the next most probable word is Elon. You probably could have known that. Okay? And now my input is this. Do you see what I have to do? Keep all the stuff until I run out of circles. And now I run it through, and my next most probable word is. And that becomes an input. And I run that through, and the next most probable word is A. I'm not kidding. This is really what it does, one at a time. But it's not learning right now. It's using the learned model. Okay, so it's much faster than if we were learning. At some point, if you have a conversation long enough, it will run out of circles, and you'll start to have some overflow. It is a proprietary secret what they do about that to try to keep some of the things around. We don't know. But 2,048, okay? All right. You also know that these are tokens, not necessarily words, right? And they aren't represented as letters. They are represented as numbers. Not two numbers, X and Y. 12,288 numbers. So let me ask my budding AI people in here, scholars in here, why 12,288?
2 to the power of 32.
Nah, it's a good idea. I mean, it may be, but. So things do, you're right, let me not say. You're right, things come in powers of 2 because that's how architecture is used. And it would be silly to have 4 slots and only use 3 of them just for no good reason. Okay, so that's why things come in powers of 2. But the answer to why 12,288 is, oh, that's what worked. And that is an AIer's answer to most all of this, okay? We ran it with 11,000 something, and it wasn't as good. So we ran it again. Do you get what I'm saying? Is this the best number? Nobody's saying that. Nobody's saying that. I might not have the architecture that can hold more numbers, more circles yet, or more numbers. Yes?
I think I'm limited in my imagination about this. I think part of me is like, so why didn't they do 3,000 tokens?
Yes.
Like it was good enough?
Yes. We only have a limited amount.
Would it have been hard to throw a few more in? I guess that's what
Yes,
I'm like.
because the number of circles that you need for this complexity, it grows exponentially
Okay.
with the number of inputs.
And
So you would have to, if you add one input circle, you're talking about a whole lot of connections to everything else.
And so is
that you'd
that
have to add.
time, money, what is that?
All of the above.
Okay.
All of the above. Processing cost, which is time, and it is circuitry, and it is coding.
So do all of the different, I don't say brand, but whatever you call them, like alternatives to the chat, use that same number, or do
No.
they all vary?
No, that's why I said when I give you specific numbers, I have to tell you about a specific architecture. Yeah. Okay. These are great questions. Y'all are doing good. Okay. Then it's one whole neural network that just learns what numbers. In other words, these are all connected, so you can think of them as a huge neural network, but to be honest with you, there are pieces of it that are specialized. Okay? And this first layer, we call them layers, is trying to just learn what numbers are best to use with each word to give me the best output. And then after that, I have layers of attention and then processing. What do I pay attention to? Okay, here's what I learned. What do I pay attention to? Okay, here's what I learned. What do I pay attention to? Okay, here's what I learned. Are you with me? Okay. ChatGPT uses 96 of these layers. The original Google paper, which was about machine translation, used 6 layers. Why? Okay, I will be honest and tell you that I know one of the people who co-authored the paper because we got degrees at Duke together back when we were doing natural language, and he works at Google. And they were up all night trying to get it, something to work, and so it worked. That was what they had. They made their problem small so that they could do something really quickly, but it worked. It worked. Why 6? I don't know, it worked. And now you try more and more for a bigger, complex task. The Google paper was written on the topic of translation, and that's an easier task than generation. Okay? All right, 96 of these layers. There's 175 billion connections, which is why we don't want more circles, right? Okay? Between them, each of which represents a number that we have to guess and tweak, and guess and tweak, and guess and tweak. Now you can see why it takes so long and needs so much data. Ooh, I didn't realize I'm out of time. Let me move forward really quickly. You may be interested to know or not, it doesn't actually give you just the most probable word unless the most probable word it thinks is more than 45%, is more than 45% sure it's that word. If it's like, it could be Elon, it actually saves a few of them and tries them for a few cycles to see which one it likes best. That's neither here nor there, but actually technically how it works. This is not a diagram that you will see on the internet. I know because I looked, I didn't want to make it. But people aren't explaining it at this level, okay? So that's why I say we're going to make this available to you. You can use it. The words that come out, of course, are tokens and not words, and are actually 12,288 numbers that we have to go look up to see what word it actually is. Now you've got the whole thing, and you're 5. Do you understand it? Oh, yes, you do. You do. It was trained on 570 gigs of text. I had a friend ask me, but how many Tolkien books is that? I said, all of them, right? This is all of the text that they can get. This would be 300 billion words, 383,000 King James Bibles, just over, if that gives you an idea. If this were all done on a single processor, it would have taken over 300 years to train it, which is why it was so important that Google had some math to tell us how to make it faster. It was then trained further by humans. So there were 40 humans that were employed by OpenAI. ChatGPT would come up with 4 different answers, and it would rank, and then the person would just say, that one's best, that one's next, and this one's offensive, don't do that. And that's how it got some of its guardrails. But that also just fine-tuned some things that even though it might be probable that you shouldn't do, or there are some things that are preferable even if they aren't probable. And so this type of training gives us that, okay? GPT means it generates, which means it writes new language as opposed to reading and doing things with given language. It is pre-trained. They didn't start the numbers at 0, okay? Neural nets have been a thing for decades. And so whatever the best guess they had up to now was, they used, and then they go from there. So those numbers aren't fixed, but they're also not starting at 0 or random, okay? They're pre-trained. And then transformer is what Google called its self-attention mechanism. And it's funny because if you look online, you might see some very complex things about why it's called transform. It transforms this into another. And the truth is, I can tell you that they just thought transformers were cool, and they didn't think attention-based network sounded cool, so they called it transformers. And I agree with them, okay? Sometimes it's very, very smart. Sometimes it can be very, very dumb. I'm going to show you very quickly in song form why this is true. Sorry, I'm turning it up. Yes. Yes. Okay, enough. But that really is honestly why it can sometimes be very, very, very smart. Sometimes it can say things you know, where in the world did that come from? Math patterns can fool you, and we never proved anything, okay? So I am going to, we're running out of time, I know. I will tell you, I'm going to make the slides available. I'm going to skip ahead to advice, okay, to end. The first thing is, if you're talking about this with your students, don't anthropomorphize it. Don't talk about how ChatGPT knows this and it understands that. It processes, it generates, okay? I wanted to pull the curtain back here today so that you understand it's just math. There's no brain, okay? And it does amazing things mathematically. It's analyzing, processing, okay? Otherwise, you're overestimating it. If you play with it, give it a chance. You can play with it once and it comes out with something really terrible, and then you can rearrange the words in what you said, which are actually asking the exact same thing but just in a different order, and you can get a very, very different answer out, okay? So don't underestimate it based on not playing with it enough, okay? Be careful when you use it for your own work. I use the same rules as to what I will ask ChatGPT as what I will post on Facebook, okay? Nothing that's private or information about anybody, nothing that I wouldn't want, that would embarrass me, that kind of thing, okay? So you know how to do this. If you use data, anonymize it, okay? That kind of thing. Fact check it. It is not trained to be correct. It is trained to sound like a human. There are some things that, to sound human, you better get correct, right? This is a good example of the emergent behavior you were talking about. An earlier version of ChatGPT, they asked it, Jack has 1 apple and I have 2. How many apples do we have together? And it would always give a number, but just a number. That's all it knew. And then they added some more, and now it does math. 3. Now they know which one. Why? Because they have more circles that can specialize with that knowledge, you see? Okay? But it is not Google. This is not, even if Bard is not Google. This is not trying to come up with the correct answers. That's not what it was built for. That's nowhere in its training at all is fact checking. Okay? Use this and make sure your students understand that. It will get some things right, and it will get a lot of things wrong. It depends on how probable those words were. That's it. Okay? There are some unethical and terrible uses for this, but I am someone who's worked in this field for a long time. I can tell you there are ethical and wonderful uses for this, such as my 12-year-old daughter who has autism being able to write some words, and I can tell ChatGPT to make a sentence for her, and it can help her express herself for the first time ever. You see? Wonderful things that we can do with it. Okay? Balance. If you only present one side to your students, that's the image they're going to have. Okay? Now, my last thing is take a minute to understand and appreciate where we are in human history. This is amazing. This is something that is absolutely astounding. For the first time, we have collected knowledge from around the world and made it accessible to anybody who can type or speak. And it's not one person's knowledge. So when we talk about DEI things, right, I can pick on Moose, okay? If I ask you something, I get his perspective. If I ask ChatGPT, I am getting a collective probabilistic perspective. That's an amazing tool. And we can learn from it, and we can use it to make some amazing stuff. So sit around and dream. What could you make with it? And then come talk to your computer science friend. Do you see what I'm getting at? Or your other friends who do this. And let's make some engaged learning things with it, faculty, because we can. We can make some really cool stuff that we can bring into our classroom, do engaged learning like never before, and do it ethically and responsibly using this amazing technology. Thank you, and I'm going to let Paula do an outro here.